Have any questions about anything? Okay, so yesterday we, I think if I remember right, worked through like half of this problem basically. This is on the 5.3 notes, this example kind of in the middle of the page. If you need a copy of those, here they are. So I think we got about halfway, but I think we'll just, sort of do it from scratch and work all the way through this. Again, we talked yesterday quite a bit about like finding a common denominator for these things. The idea there is that, to get to a common denominator, you're, sort of multiplying by one in like the right way. So we kind of have to build up to it. So if I've got fractions that have x minus 2 and x plus 2 in denominators, I got to, include that in the least common denominator. So it's got to have a factor of x minus 2 and a factor of x plus 2. X squared minus 4 just so happens to factor as x minus 2 times x plus 2. So that, sort of takes care of everything, right? So I can factor this, and I'll go ahead and do that as x minus 2 times x plus 2. If you're, still not super comfortable with factoring, a good place to start or to check would probably be multiplying those things out and seeing what you get often. You're going to find that, those end up being the same thing. Then to actually do this, we took that common denominator and multiplied both sides of the equation by it. So I'm going to multiply the left and the right by x minus 2 times x plus 2. What that's going to do, because we're taking a bunch of fractions and multiplying them by, factors that include the denominator, is that a bunch of stuff is going to cancel. So we did this just kind of one piece at a time. This stuff's going to distribute on the left-hand side. And just, again, kind of looking at it one thing at a time, when x over x minus 2 gets multiplied by x minus 2 and x plus 2, what happens? Some stuff cancels, right? There, the x minus 2 terms would cancel. And what's left then? X plus 2 times x. Plus, okay, then do the same thing here. X minus 2 times x plus 2 times 1 over x plus 2. Those cancel. And you're left with 1 times x minus 2. Then on the right-hand side, x minus 2 cancels. X plus 2 also cancels. We just have 8. Expand. Combine like terms. I'm going to move the 8 over also. And we have that. I think that's where we called it yesterday. And I said, go home and finish that, right? Okay. So you went home and finished that. And what'd you get? -5 and 2. How'd you do it? Okay. Yeah, so this is quadratic, so you can factor it. You can use quadratic formula. -b squared 4 times a times c over 2a. So that's -3 plus or minus the square root of 49 over 2. And if you do those, you should get -5 and 2. Or factor. Okay. I will say that, you know, typically like I write problems, you know, stuff that you're gonna see on like a quiz or test or whatever. I try to write the problems here so that if you're solving a quadratic, like it doesn't have to be quadratic, it could be linear or whatever, but the solving part here shouldn't be like really messy, right? Like it's, you know, gonna be something that, you know, works out okay. It's not gonna, you know, shouldn't be a whole big thing. Anyway, however you solve it, but you get -5 and 2, right? Everybody okay with that part? Okay, the other thing I asked you to do is think about those as solutions, right? Or as you know, whether those make sense if we sort of track everything back to the original problem right here. Does x equals -5 and x equals 2 make sense at, hang on, do x equals -5 and x equals 2 make sense as solutions? And what do we think? Does anybody see anything that would be a problem? Say it again, but like 1,000 times louder. If you try to plug 2 in, what happens right here? 2 over 0. The same thing doesn't happen with -5, right? -5 is fine all the way across. Now, like if I plug it in, it's gonna be like -5 over -7. Like I'm not saying check all the arithmetic, because assuming that we did everything else right, the arithmetic is gonna work out fine. But remember, I kind of made a big deal yesterday about like when we go from one kind of thing and we do some of this kind of stuff, right? There's more going on here than just like moving a 3 from this side of the equation to the other side or something, right? We are going from one kind of a thing, right, from a rational equation or rational expressions here, taking it to a polynomial. We're like changing the type of thing, right, in like a deeper way than just like moving stuff from one side of the equation. When we do that, we can lose track of things, right? And what we lose track of here is all that stuff about domain and vertical asymptotes and that kind of stuff, because I took variables that were in the denominator and I moved them out of the denominator, right? So we lose track of that problem with dividing by 0. When we do that, we can run into this kind of thing that, no, that doesn't make sense, right? That doesn't work because, again, it would give you 0 in the denominator somewhere. So the only actual solution to the equation is x equals -5. X equals 2 is like a false positive kind of thing. Like it shows up like it works, but it doesn't actually make sense in the original problem. So often, like what I usually do with these to, you know, make sure that that's kind of at the front of mind when working through it. Because I mean, if you look at this whole thing, we did the new thing, right? Find the LCD and multiply and get rid of stuff. But then we went into like solving quadratic mode and we worked through, you know, 10 steps of stuff. Like there's a lot going on. And when you get, you know, caught up on the like step-to-step mechanic stuff, you forget to think about the big picture sometimes. So my advice for this kind of thing would be at the very beginning, when you're looking at the thing, maybe even like off to the side somewhere, make yourself a note that x can't be 2 or -2, right? Because if x is 2, you get 0 in the denominator here. If it's -2, you get 0 in the denominator here. If it's either of them, that one is 0. Those are a problem. So when I, work through everything and get down to my solutions, I need to check these to make sure they make sense. Well, checking them could be comparing against the list I already made myself of things that don't work, right? So I'm already kind of thinking like, okay, there's some things that would not work here, right? You're not necessarily always going to get, solutions here that, sort of match up with that list. Like they could be totally unrelated. But when I do that check, I have to toss 2 out. And so x equals -5 is our only actual solution. That all kind of makes sense? Yeah. Okay. So again, like, I don't really care like how or when you do that, but you do have to do it. You have to, make sure that your solutions make sense in the original problem. Somehow, right? At some point, whether that's at the end, going back to the original problem, plugging in to make sure that you don't get 0 in the denominator somewhere, or, right off the bat saying, okay, I know that these things are not going to work, so I'll just keep that in mind as I work through stuff. But you do need to, be careful to look at that or think about that. Okay. All right. So flip over to the back. There are 6 problems there. The first 4 are the first 4 that were on the front that we like already done the least common denominator. We already did a little bit of the setup stuff. The other 2 are new, but we're gonna spend, I don't know, 20 minutes or something. Y'all just try some of these, work together. You're already in groups and stuff, except you guys at the back. You guys move and talk to each other. But work problems, let me know when you have questions. This is not enough room to do them, so don't try. And we'll talk about some things all together in a bit here. All right. Which one of those you guys want to look at? Yeah. So. Okay. Yeah. Let's look at number 3. Okay. So 3 is 1 over x plus 2 plus 3 over x plus 7 is 5 over x squared plus 9x plus 14, which we know factors as x plus 2 times x plus 7 because we did it yesterday, right? So that's also the least common denominator. So again, I'm going to multiply this whole thing through by that. I am also, because it's my way, going to write myself a note that x cannot possibly be what? -2 or -7. Because one or more of the pieces of the original equation would be undefined at -2 or -7, right? So -2, -7 are not in the domain of the stuff that's going on in the original problem. So they can't be solutions to the equation. All right, so do the multiplication. This thing gets distributed through here. When it hits that first term, x plus 2 cancels, right? So what do we get? 1 times x plus 7. Multiply it to the second term, and the x plus 7's cancel. So we get 3 times x plus 2. And then on the right, x plus 2 and x plus 7 both cancel, and we just get 5. Everybody okay with that? Yeah, okay, so we've got x plus 7 plus 3x plus 6 equals 5. combine like terms. So 4x plus 13 equals 5. This thing is just linear, right? X to the first. So to solve, I'm just going to get x by itself and move everything to the other side. So subtract 13 and then divide by 4 and we get -2. Colby, what was your question? That doesn't work, right? Because we started with looking at, the original problem, figuring out the common denominator, all that kind of stuff. There's a factor of x plus 2 in a denominator somewhere. So if x is -2, you get something divided by 0 here, right? And also here. But if it happens anywhere, it's a problem. So can -2 be a solution? No. So this has no solution. So that can happen here, right? You can, realistically, like, stuff I'm actually, might actually ask you to do. You're probably not going to have to solve anything more complicated than a quadratic. Quadratics can have as many as 2, but we could have stuff that we throw out. So you might get 2 solutions that work. You might get 2 and one of them is no good. You might get 2 and neither one of them work. You might get 1 and it doesn't work. You might get 1 and it does work, but you got to check, right? And also you need to, like, looking ahead to grading or thinking about, test problems or whatever, you need to communicate to me somehow that you are checking, that you're thinking about whether solutions make sense or not, whether they do or don't. So just make sure that you're, doing something somewhere, whether it's, up here or saying like, just write like check and then like do it. You don't have to write out plugging the value in or anything, just be thinking about it. Okay. Good with that. Okay, I did want to talk about 6 because 6 looks different, right? 6 doesn't look like it's the same kind of thing. We've got x to the -4 minus 3x to the -2 minus 4 equals 0. What do negative powers do or represent? It's a reciprocal. So, for example, like x to the -1 means the reciprocal of x. X to the -2 means the reciprocal of x squared, or 1/x squared, and so on. So what's really happening here is that x to the -4 is 1/x to the 4th minus 3 times x to the -2 or you could also write that as 1/x to the 4th minus 3/x squared minus 4. There are a couple of different ways you can go with solving that thing. You could approach it the same way we've been doing all these others, find a common denominator. What would the least common denominator be for these things? X to the 4th, right? Because you got to go up to the bigger one. So the LCD would be x to the 4th. If you multiply everybody by x to the 4th, all of the fraction stuff goes away. X can't be 0 because you've got factors of x in the denominator, so it can't be 0. But multiply by x to the 4th, all the fractions go away, and then work through solving that. Or you can treat it now like it's a thing that's, we talked about this idea of treating a thing like it's quadratic in form, right? Treat it like it's quadratic, but fix it so that the powers work out right. When did we do that? 4.4, I guess. I don't know, somewhere in chapter 4. You can treat it that way as well. So I'm gonna let you guys, I'm gonna leave that one here for now. And if we want to, talk about it together on Monday, we can, but I want you guys to give that one a shot. So LCD is x to the fourth, or try to factor like a quadratic. The factors are just going to be a little bit different because it's not just, x squared minus 3x minus 4. It would factor the same way. You just have to make an adjustment in what the first part of the factor would be. That way. Okay. Any of those that you didn't get to here, just work through them. Solutions are in Blackboard. If there are any of those that we want to talk about later, send me an email, or we can talk about it on Monday if we need to. Inequalities, real quick. Here's a graph of a thing, right? So this curve in red, this is y equals f of x. If we're going to think about solving where f of x is equal to 0, right? Saying it's equal to 0, what does that mean? What are we looking for there? Anytime you set a function equal to 0, you're finding its x-intercepts, or it's zeros, right? Okay, so where does this have x-intercepts? -2 and 2. Right, that's just finding its zeros or its x-intercepts. Okay, now if we're going to ask about solving an inequality, though, asking where it's greater than 0 or less than 0, think about where we've done inequalities up to this point. We needed to find the zeros and then sort of test around them and see what happened, right? Figure out, either with a graph or by plugging in points, does this sit, above the axis or does it sit below the axis? We do the same thing here. Where is f of x greater than 0? Well, that would be where it sits in the top half of the plane, right? So here's the top half. We'd be looking for where it sits up there, right? And not anything where it sits below the axis. Well, that would be between those two zeros, right? Because you get this little loopy bend on this little wobbly parabola kind of thing. So it'd be there, but where else? About here. That part of the graph sit in the upper half? Yeah. And this piece does too, right? Well, if all I did is set it equal to 0, those don't show up, right? Like, how would you write the solution set, the interval notation for that, the second bullet point, greater than 0? -infinity to -3. And then -2 to 2. And then 4 to infinity, right? Because there's this piece. I should use a different color. There's this piece, and this piece, and this piece, right? And those are all sitting in the upper half. So they're all greater than 0. So we get kind of one extra thing that we need to look for, right? I don't just need the zeros, because yeah, the answer to that, whether that inequality is true or false, that changes at the zeros, right? Or it can, just like, always, just like anything else. But where else can it change here? Think about reading it left to right. If I'm walking along the x-axis this way, reading the x values. Anywhere out here, right, this is -infinity up to -3. Anywhere out here, the y values, the function values are positive or negative? Positive, right? It's up here. Okay, so they're all positive, still positive, getting steeper, right? Very much positive. Then you get to this vertical asymptote. where the thing breaks, right? Or it's discontinuous because you divide by 0. So I like, hop over that. But then what happens as soon as I get to the other side? Well, now the y values are negative. Until I get to this place where it crosses, right? It's 0, and then it changes again. And it changes again here to negative. Then again, an asymptote, and I hop over that and the positive again. So it can change, at zeros, just like always, but it can also change at any vertical asymptotes. So I need to look out for sort of both of those things. So if I'm going to solve an inequality like this first one, just like we always have with any other kind of inequality, on one hand, I need to find the zeros, right? I need to solve the equation. When you solve that equation, even if you want to think about doing it the same way, like multiply both sides by the LCP, it cancels here, and here you're multiplying by 0. So that would mean that x plus 3 is 0. So x equals -3. But I also need to figure out if there are any vertical asymptotes and where they happen. So does this have a vertical asymptote? Where? Said that equal to 0, right? So to figure out the inequality, -3 and 1/2 are the 2 points that I need to be checking like around, right? Because those are the 2 places where this can change. 1/2, there's a vertical asymptote. -3, there's a 0. Then again, you can test this either with a graph, right? So I could graph y equals x plus 3 over 2x minus 1. So I can graph it that way. You see there, the 0 at -3 and the vertical asymptote in here. All I really need is kind of the general shape of the thing. It's doing something like that. Or you could do the plug-in points and test that way thing. Right? So for example, like -4 plus 3 over -8 minus 1, that's -1 over -9. That is positive. So back to the original inequality, is it greater than or equal to 0? Yes. 0 would be 3 over -1 is negative, so no. And 1 would be 4 over 1, so positive. So yes. And then write down the solution set, right? -infinity to -3. 1/2 to infinity. This part is not anything new. This part is not anything new. The one extra thing that we got to think about is that now, different than stuff we've looked at so far, is this extra level of having like domain issues that we have to be careful about. And because these can have vertical asymptotes, and because from one side of a vertical asymptote to another, you might go from negative to positive or vice versa. You don't have to. They can both be, you can have a vertical asymptote that looks like, that, right? Where, sort of both ends are pointing up around the vertical asymptote or both down. Like that can happen too. It doesn't have to change, but it can. So we got to, take that into account when we think about it. So solution set here would be -infinity to -3. and 1/2 to infinity. What should we do with the endpoints? Square bracket or parentheses? The one at a time, -3, should -3 be included? The question was greater than or equal to, and what happens at -3? It's equal to. So what about 1/2? No, why not? Because what happens at a half? You get an asymptote, right? It doesn't touch it, doesn't reach it, so that one's open. Okay, so again, just kind of like what's coming up. 5.1, 5.2, that's graphing, finding domain, finding asymptotes, all that kind of stuff for rational stuff. Those are due on Monday. 5.3 is also due on Monday. That's solving equations and inequalities. And there's some like word problems stuff thrown in there. You guys go and do stuff and work problems. Monday, we don't have anything new to talk about. I've got a like worksheet with some more practice problems. We can work on more of this stuff if you want. We talk about homework questions if we need to. If end of class Monday comes around and we still don't feel super comfortable with 5.3 stuff, I'm fine with moving that back a little bit. I'm not fine with moving it back. If I look at it Monday morning and nobody's touched it though, then I'm going to be quite grumpy. So like go and do stuff and try things. Monday is, make sure we got everything locked down and we're good to go time. Okay. All right, y'all have a good weekend. I'll see you on Monday.